Today we're going to be talking about transformations. Our objectives is that we will be able to solve problems involving symmetry and transformation, and we will be able to determine whether a figure has been translated, reflected, rotated, or dilated using coordinate methods. So, a transformation occurs when a figure changes or moves. The pre-image is the original figure, and the image is the figure after the transformation. So the first of the four transformations we're going to talk about today is line reflection. It's basically when there's a line and the pre-image flips over that line to create a new image. So reflect the quadrilateral over the line x equals 1. So line x equals 1 is right here, where all the x values are 1. So we're going to take each of these 4 points and flip it over the line. So this point right here, since it is 1 space away from the line, it's going to go 1 space on the other side. Here is 1, 2, 3, so 1, 2, 3. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this one is 1, 2, 3, 1, 2, 3. And if we connect our dots, we have a mirror image of that original figure. So for reflection, think mirror image, just like you see your reflection in a mirror. Translation. Translation means the figure is going to slide. So the vertices of triangle ABC are at 1, 1, and that's A. B is at 3, 4. And C is at 5, 0. Draw my triangle. Graph the pre-image, which we just did, and the image by translating left 3 units and up 2. So we're going to take this dot and we're going to go left 3, 1, 2, 3, and up 2, 1, 2. And that's our A, and we put the little apostrophe mark. It's called A prime. It's the notation for our image. B, we're going to go left 3, 1, 2, 3, and up 2, 1, 2. B prime, and for C, we're going to go left 1, 2, 3, and up 1, 2. There's C prime. I'm going to connect these in a different color to make it a little easier to see. And the pink triangle is now our image. Write the coordinates of A prime, B prime, and C prime. So A prime is at -2, 3. B prime is at 0, 1, 2, 3, 4, 5, 6. And C prime is at 2, 2. And if you notice, left 3 would be -3, -1 minus 3 is -2, 3 minus 3 is 0, 5 minus 3 is 2. That affected the x values. Up 2 would have been +2. We added 2 to all the y values. 1 plus 2 is 3, 4 plus 2 is 6, 0 plus 2 is 2. So we could have done it algebraically first and then graph them. What if we have to perform 2 transformations at once? So triangle FMA is reflected about the y-axis. So here's our y-axis. We're going to reflect it over that and then translate it up 9 units. So F would go 1, 2, 1, 2, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our F prime. Now we could keep going, but the question just asks, what are the coordinates of point M after the transformation? So I'm not going to worry about A. I'm just going to do M. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be M prime. So let's see where that coordinate is. 1, 2, 3, 4, 5. So negative 5. 1, 2, 3, 4, 5. Positive 5. So a rotation turns a figure a given number of degrees around a point, usually the origin. So here, it wants us to rotate the triangle 90 degrees counterclockwise. So we're going to follow this right here. So I'm going to start by writing down the 3 vertices of the triangle. So we have 2, 2. We have 1, 2, 3, 4, 5, 1. And we have 4, 1, 2, 3, 4, 5, 6. So that is our A and our B. To go 90 degrees counterclockwise, we want negative B and A. So I'm going to start by switching all the coordinates because the order switched. And then we're going to change the sign. So we're going to make all these the opposite sign of what they were before. And now we can graph these. Negative 2, 2, negative 1, 5, and negative 6, 4. So it just looks like we took it and we turned it a little bit. Our final type of translation is a dilation. Or sorry, type of transformation is a dilation. This is a stretch or a shrink of the figure. So our original figure is this blue one, A, B, C, D. And it gives us A prime, B prime, C prime, and D prime. So we can tell that it's stretched. So we want to know what factor it was dilated by. How much did it increase in size? So let's look at some coordinates. A's original coordinate was negative 1, negative 1. A prime's coordinate is negative 3, negative 3. B's original coordinate was 0, 1. B prime's coordinate is now 0, 3. What do you notice are happening to these numbers? Let's look at C. That was at 2, 1, and C prime ends up at 1. There's 5, 6. Oh, sorry, this was at 2, 2. And it ends up at 6, 6. And D was at 3, 0. And it ends up at 5, 5, 6, 7, 8, 9, 9, 0. What do you notice about all these coordinates and how they might be changed into these coordinates? Hopefully you said that they were all multiplied by 3, and that means we have a dilation with a factor of 3. They were all multiplied by 3. If the figure were to get smaller, then we know that our factor would have to be a fraction so that it's a smaller size than the original. That's all for today. See you